Hi there. In this section, you are going to learn about modulus and conjugate of complex numbers. You will also learn the properties related to that. So let's begin. Modulus of complex number. Let us consider a complex number z equals to a plus iv, where a is a real part of the complex number and b is an imaginary part of the complex number. If you remember, when we talked about the complex number, we also talked about how to write a complex number in ordered pair form. So basically a and b, they can be written in the ordered pair as a complex number where a is the x component or along the x-axis and b is along the y-axis. So in order to understand the complex number z equals to a plus iv, what I'm going to do, I'm going to graph it. So this is my graph. This is my x-axis and this is my y-axis. I'm going to consider a point P. So this is my point P, and the coordinate of this point is a comma b, because I'm writing the complex number z equals to a plus iv in terms of ordered pair, which is over here. If I want to find the magnitude of this complex number, what I need to do, I need to connect point P with origin. So this will be my complex number represented by z equals to a plus iv, where real and imaginary parts can be written in ordered pair and denoted by point P. What I want to do, I want to find the magnitude of the complex number. So basically I'm going to drop a perpendicular from point P, and if I drop a perpendicular, I will get a right triangle. So I have two possibilities to find the value of complex number z. One way is I can use the distance formula and find this length, or I can use the Pythagorean theorem to find this length. So if I do that, I will get the modulus of the complex number, which is basically the value of the complex number. Then the modulus of g is represented as this symbol, is given as modulus of z is equal to square root of a square plus b square, which is a non-negative real number, which simply means that when we find the modulus of any complex number, we will get a real number